I've just downloaded this sort of status report for new cases. It's Sunday the 13th, late in the evening today actually. So cases still going up in Canada. Germany have had quite a big increase. They're going into a semi-lockdown from Tuesday, in fact. But the United States, I'm afraid, continues to increase. This slight flattening you see here is just an effect of the data reporting at the weekend. So the trend is still upwards. And these are the places, these are the countries with the most new cases at the moment. Just a bit of a snapshot of them there. Georgia, Serbia, Lithuania, Croatia. Do hope you got a chance to listen to that report from Croatia the other day, the excellent report from our journalist in Croatia. He's actually a proper journalist, but he kindly agreed to do a programme for us. United States here, and then Netherlands, Slovakia also increasing. So these are the kind of countries that are on the way up at the moment. And you are very welcome as always. Now, bit of an update on some vaccines. The vaccine rollout in the United States. Really good to see those trucks rolling out and vaccines getting loaded onto aeroplanes and things like that. So that's good. And as time goes, I've got a bit of a study to look at about genetic predispositions, which is interesting if you want to hang on for that. Now, starting off with some not so good news, to be quite honest. The Australia vaccine. University of Queensland, they were developing their own vaccine. Basically, the whole program's been cancelled. Now, what it was, they were using a component of it that was from the HIV, the human immunodeficiency virus that causes AIDS, of course. I mean, nothing that could conceivably cause AIDS. There was no danger to the participants. They were just using part of the AIDS protein in their vaccine. But what it meant was that the individuals who had the vaccine in the trial tested, or some of them tested HIV positive. Now, they did look at these people very thoroughly, and they did find out these were false positives. In other words, these people had developed some antibodies to HIV, but did not have the HIV virus. But it just would have completely wrecked public confidence in the vaccine, really, if people were testing positive to HIV, even though they weren't HIV, they didn't have the HIV virus. The tests would still bring them up positive to that. So that was dropped. Now, this isn't too surprising, really. Many vaccine projects are dropped. We've been fortunate with the initial ones that have gone so well. Just a quick look at this, though. Quite interesting. University of Queensland. The Australian government had ordered 50 million doses, so they were quite hopeful for this. 200 volunteers in two groups. One group was aged 18 to 55, one group was aged 56 and over, men and women in both groups, and some were also given a placebo to compare them to. So good study, basically a phase 1 study. So it was healthy people in the study, basically a phase 1 trial. Now, they said it was safe and produced a strong immune response. Now, basically, this is so encouraging because it means that every vaccine that we've got data for so far has produced a strong immune response. Now, back in February, March, this was by no means clear. I remember Chris Whitty saying that the chief medical officer in the UK, or was it the other one, the scientific officer, Patrick Vallance, one of them. Patrick Vallance, I think it was. He said, well, we'll probably end up with something. You know, he wasn't over-optimistic at the time. But all the vaccines that have been developed so far seem to produce a strong immune response, and this is really encouraging. It's as if this virus is let's make up a word, vaccinable or something like that. It seems amenable to vaccines. So that's good news, I think. And the fact that it's been true for several vaccines so far probably means that it will go on to be true for other vaccines. So it's remarkably encouraging, even though there's this bad news from Australia. Safe and produced a strong immune response. So the program's terminated after they spent $4.5 million on it. Now, when you think about the amount that have been spent on things like the Pfizer and the Pfizer BioNTech and the Moderna National Institutes of Health, we're talking billions of dollars. So this was really quite cheap. And the Oxford-AstraZeneca one has only cost tens of millions of pounds as opposed to hundreds of millions of dollars. So it's a bit strange, this discrepancy in the cost of vaccine programs, but there we go. We don't know too much about that. We might do in the future. So, okay, no big deal basically. It was worth a try. So several participants had false positives for HIV tests. There was no health risks. So the Australians instead have ordered 20 million doses from Oxford AstraZeneca and another million doses from the Novavax one that's coming up. Now the Oxford AstraZeneca one, I'm expecting that to be approved by the British authorities. Really, probably next week, could well be next week. The American authorities may be a week or two after that. European authorities aren't even meeting till the 29th of December. And the other good thing about the Oxford AstraZeneca vaccine is it's actually being produced. There's a production hub in Australia. So I suspect most Australians are going to end up being vaccinated by the Oxford AstraZeneca vaccine, which is fine. The Australian vaccine network, that would have been brilliant, but they've pulled the programme, so there you go. But some encouraging data, although disappointing overall result. Now, really good news. The American rollout of the vaccine is on way now. It was really good to see the news reports. So there's General Perna is in charge, logistical expert. Logistical people get the right stuff to the right places at the right time. That's their job. Now the factory's in Kalamazoo in Michigan. Going out by flight and road, of course, we have the complication that you have to go out in these containers at -70, which is -94 degrees Fahrenheit. And then once they're opened up, they can only be used within 3.5 days. At least that's what's happening in the UK. I assume it's the same in the States. So first dose is arriving tomorrow, 145 sites on Monday. A further 425 sites on Tuesday, and another 66 sites to complete the initial site rollout on Wednesday. So very similar to the UK really, where we have these 70 hubs where we can maintain the cold chain and the temperature. All the boxes have got tracking devices, they've got temperature devices, the cold chain is guaranteed. It's a tidy job and a tidy piece of logistics. And if this all works, and I strongly suspect it will, Monday, Tuesday, Wednesday, it will be a good start. Half of the 6.4 million doses sent out. So they've sent out 3.2 million doses. Now, the rationale here is that they are keeping the rest in reserve because, of course, you need 2 doses of this vaccine. So the other half is to vaccinate the people that get vaccinated now in 3 weeks' time. This surprises me a bit because I would have thought by that time they'd have further supplies rolling out. So I would have thought they could have vaccinated 6.4 million people and have produced another 6.4 million vaccines in 4 weeks time, but it doesn't seem to be the way it's working. So slightly disappointing there. Not quite sure why they're not going for that. Anyway, Pfizer, 50 million doses in 2020. You see, this is what doesn't quite make sense, but this is what they're saying. The news reports are saying they're keeping half back, and yet they're talking about it getting another 50 million doses out in 2020. Half of these are going to the US, so the US is due another 25 million doses in 2020. More than enough to vaccinate the other 6.4 million, but there you go, that's what seems to be happening. The US is getting 100 million doses altogether. Now, it's somewhat disappointing for the United States because they've ordered this 100 million doses, but they're not going to be able to get any more than 100 million doses, enough to vaccinate 50 million people. It's a good start. But they're not going to be able to get any more due to manufacturing limitations until summertime, probably May, June, because of the commitments that Pfizer have made for pre-orders in other countries around the world. So I don't think that's the hiccup. I think they're going to work around it with other vaccines. Now, this is interesting. In the UK, it's 18 and older. In the States, it's approved for 16-year-olds and older. But the Moderna vaccine is got to be on the way. Now, I would be pretty amazed if we don't get authorization in the UK and the US for the Moderna vaccine in the next week, 10 days at the most. So this is coming as well, and of course that's going to greatly increase the numbers. So that means so that's going to take it up to 20 million Americans that can be vaccinated in 2020. So as long as this Moderna vaccine is approved, and it is certainly, surely going to be, I know of no reason that, well, there's no reason in the public domain why this isn't going to be approved. It will be approved unless there's some information that the FDA and the agencies in the UK have to say it can't be approved. If there's a problem, it's not in the public domain, so I'm expecting it to be approved. So more good news. 20 million Americans can be vaccinated in 2020. That meaning, of course, there'll be a total of 40 million doses of vaccine rolled out. Good. Although you'd think it'd be more than that, because Pfizer are talking about getting 50 out. But the new, this is a bit frustrating, really. This is what the news reports are saying. So, this is all we can go on at the moment. It's a good start anyway, and the Moderna one's going to really improve things anyway. Moderna, another 200 million doses in 2021. Now, the United States are confident that they can vaccinate everyone in the United States who wants to be vaccinated by summer 2021, June, July 2021. Impressive stuff. And I feel sure that as more people get vaccinated and people see that it's working and that it's safe, as the clinical trial data shows, that more and more people will be vaccinated. Now, I'm not going to put it on this video, but I was doing an online, I do these online lessons, so we're doing an online lesson in collaboration with friends in Tanzania. And it was actually quite distressing. People there were worried about some of these far out conspiracy theories. It just shows there's so much disinformation out there that's concerning. I'm going to have to edit it together and I'll show you some clips of that. But the disinformation about vaccine is quite concerning. We go on science and we go on evidence. Talking of which, that brings us on to the China vaccine. Interesting. Now, the China vaccine is an inactivated vaccine. Right, so we know that the Pfizer and the Moderna vaccines are these messenger RNA vaccines, the instructions to make the antigen. We know that the Oxford-AstraZeneca vaccine uses an adenovirus vector from a chimp. Well, the China vaccine is the most old-fashioned of all. And I must say, when I first heard this, I really quite liked it because it's kind of a tried and trusted technology. So basically, all you do is you breed up a load of the viral particles, the SARS coronavirus 2, and you inactivate them. Normally, you would kill them. Sometimes just attenuate them, but in this case, I think they've killed them. And then you can inject that. So you're injecting dead SARS coronavirus 2, which of course can be recognised by the immune system. So it's an old-fashioned approach. It's just an inactivated, as far as we know, dead SARS coronavirus 2 viral particles, to which the body will raise an immune response. So that's that type of vaccine. It's called Sinovac. It's produced in Beijing. Sinovac is the company, I think, and Coronavac is the name of the vaccine. So it's called Coronavac. Now, it's arrived in Indonesia at the moment. It's going to arrive in Turkey, Brazil and China, we believe, in the next weeks. Another 1.8 million doses by the beginning of January are going to be shipped out. Great thing about this vaccine, fridge temperatures, no problem at all with the cold chain. Ice box, few blocks of ice, go out for the day, do your vaccinations. Same as the Oxford-AstraZeneca one. Just ordinary fridge temperatures, none of this high-tech stuff that's needed for the Pfizer vaccine. And to a lesser extent for the Moderna. The Moderna's -20, it needs to be transported at. Now, the phase 3 results of the China vaccine, although it's been rolled out now, are going to be published, we believe, this Wednesday. So it's a couple of days yet, but they've actually started already. So somewhat jumping the gun, but being rolled out in China, we believe. But one would imagine that the Chinese authorities know that the results are good to allow the rollout. But officially, published on the 15th of December, so that'll be something to look out for this week with interest. They can produce 300 million doses a year. Now, in Africa, they've earmarked $2 billion worth of vaccines. In Latin America and the Caribbean, they've earmarked $1 billion worth of vaccines. Now, how the Africa one's going to be paid for, we don't know. The Latin and American and Caribbean one is going to be paid for by a loan, as far as we know. Now, this is outside the scope of this podcast, but you really can't ignore the geopolitical implications of this. The vaccine diplomacy, the money. There's clear implications here that someone more versed in these things than me can talk about, but there's clearly geopolitical implications in this. Now, what about the cost of the Chinese vaccine? Well, Moderna are producing 500 million doses in 2021. Oxford-AstraZeneca 700 million doses by April. Fantastic level of production. This one is about £3 per dose. Can't remember the precise figure on Moderna. It's probably about 10 times that. Quite a lot more than that anyway. It's quite Moderna's the most expensive one so far, and the Chinese one's going to come in somewhere between. We're probably looking at about $10 to $15 per dose, as far as we know, for the China vaccine. Whether they're making a profit on that, we simply don't know. Okay, so that's a few interesting things on vaccines. Now, there's been quite a lot of discussion in my country about this UK break. So UK Christmas 5-day relaxation period. Travel from high to low risk areas will probably take place. Up to 3 households can stay together in a Christmas bubble from the 23rd to the 27th of December. This applies to all 4 nations. Ireland, Northern Ireland, Scotland, Wales, and what's the other one? England. Now, the fact that this is allowed doesn't mean say it has to be done, but people will be allowed to do it, so there's going to be a substantial number of people do. Therefore, we're going to have guaranteed spread. It's that simple. We said this before Thanksgiving. Tragically, we're now seeing the results. I'm saying this before Christmas now. We will see the results of this in January, depending on how many people choose to exercise this freedom the government has given them. The government have made this decision. They could undo it. Well, it'd have to be all 4 governments would have to undo it. They would lose an awful lot of credibility, but even so, I still think they should do that. Because we are going to get a big spike in cases in January, inevitably. And of course, there's a Christmas in Canada and the United States. Most places in the world there's a Christmas. And we're going to see more transmission during that time period. Certainly throughout the UK we will. The price will be paid in January, and there'll be more deaths at the end of January, beginning of February, as a result of this Christmas policy. It's that simple. Yet that is what is happening. All I could say is talk to people round about you, encourage them to realise that they are risking the lives of their relatives with comorbidities and their older relatives by mixing with generations and households. Do they want to play Russian roulette with the lives of their elders? Because they are doing. And it's never guaranteed that anyone's going to get over this illness. So there's still some risk for younger people. Lower risk, but the risk is not gone away. It just seems so tragic to me to do this when the vaccination herd immunity is so close. Right, but that's the situation. So there we go. Strange, but true. Now, last thing I'm going to do is there's been quite a lot of publicity about genetic predispositions to this virus. Now, of course, it's obviously true that all disease conditions are caused by a combination of genetic and environmental factors. You know, if someone asks you, I used to say to the students, if someone asks you what the cause of this disease is, put on a straight face and say, well, the etiology of this disease is almost certainly a combination of genetic and environmental factors. And of course, you're always right, so it's a bit pointless. But anyway, let's look at the genetic disposition here for people getting quite ill. Now, this is a paper published in Nature. A lot of the work was done in Edinburgh in Scotland and other places. think they got some money from the Rockefeller Foundation, I'm not sure. Anyway, genetic mechanisms of critical illness in COVID-19. So that's the popular news outlet from the BBC. That's the official paper that we went to for this study, of course. So susceptibility to viral infection has a genetic component, we know that. Propensity to develop harmful pulmonary inflammation has got a genetic potential. The question is how big, what genes, and the crucial thing is if you can identify the genes, how they're working, then that suggests a potential therapeutic that we could use against that. And we'll see an example of that, 2 examples of that in fact. So genetic factors are involved in susceptibility to life-threatening infections. So how likely you are to get infected and how quickly the infection spreads has genetic component. And then the immune-related response to the disease has also got a genetic component. In other words, there's a genetic component that determines how sick you are likely to get with a particular infection. And there's also a genetic component that says how likely you are to have an abnormal inflammatory immune response to that infection. And of course we know that that is a big part of the problem with the acute respiratory distress syndrome. It's not the virus, it's the body's reaction to the virus. And we know this from this picture we've looked at quite a few times from East Virginia Medical School. Viral replication here in the first over by 11 days after infection there. But the immune dysregulation, the cytokine storm, the alveoli filling up with fluid is happening when the viruses are already dead. But we believe the more viruses there are here, the more stimulation there's going to be of this inflammation here. That's why people who have a lower viral load are probably less likely to get this immune dysregulation. As far as we know, that's where current thinking is going. But anyway, what we're saying is both of these are not determined, affected by genetics. Host genetic variants. Now in humans 99.9% of the DNA is all the same. In people that are the least related. So if you take someone from one part of the world and someone else from another part of the world, as far as unrelated as you can possibly imagine, they might not have had a common ancestor for 20,000 years or longer, probably much longer actually. Then 99.9% of the genetic material is still the same. But that 0.1% of course can make quite a big difference. It can affect the way that you look and it can affect your predisposition to disease. Just that one little bit of difference. So they did a genome-wide association study. Now this is amazing. I forget, there's 3.1 billion. I think there's 3.1 billion base pairs make up the DNA. 3.1 billion genetic letters in the DNA in every cell of your body apart from the red blood cells. So what they did was they did whole genome sequencing. Now 20 years ago or so they published the results of the Human Genome Project, and that took years of work and huge amounts of money under Francis Collins. Now you can do a human genome in an afternoon for around about $1,000. Probably even less than that now. So what they did was they compared people in intensive care. They compared their genomes with people who were healthy. They compared those 2 genomes. So people who were in intensive care with the infection, people who got the infection who didn't get critically ill, and they compared them. Comparing 3.1 billion letters. I assume they had computers to help them. Otherwise it would have been a long job. Now, good study, very good study. 2,244 critically ill COVID-19 patients. So that was from 208 intensive care units in the UK. They get this genetic information, the 3.1 billion letters in the DNA, from blood samples, from blood cells. The white blood cells, of course, carry the DNA. The red blood cells don't. Genome-wide looking for significant associations. So the computers just compared the 3.1 billion letters in those with severe disease and the 3.1 billion letters in those without severe disease. Because we have the potential here for repurposing licensed medications. That's good. We looked at that just the other day when we looked at ivermectin. We looked at it with hydroxychloroquine, albeit the results were not good with hydroxychloroquine. Ivermectin results yesterday, we did call on governments to urgently review this data. Now, anyway, carrying on with this study, association with severe COVID-19. Now, some people had a low expression of this gene, IFNAR2, which is on chromosome 21, and that resulted in lower production of interferon. Now, interferon is one of the important antiviral cytokines. It's one of the good guy cytokines, one of the antiviral cytokines. And this genetic variation meant that people were very sick, were producing less of this antiviral cytokine. And they estimated that accounted for 15% of critically ill COVID patients, just this one gene. So the lack of interferon. So interferons are so called because they interfere with viral replication. They produce antiviral enzymes to prevent viral replication. They inhibit protein synthesis. And of course, viruses are proteins, so the cells can't produce the viruses because the protein synthesis of the cell is inhibited. And they also stimulate local immune cells. And the interferons also cause fever, muscle aches, and general malaise, all of which, of course, are good. So why am I saying it's good to have a fever, muscle aches, and general malaise, feel unwell? Well, the fever boosts the efficiency of the immune system. The muscle aches means you don't move around, which is good because you need to rest. And the general malaise means you rest and behave as if you're sick, which of course you are. So all quite good. Now, this is actually the diagram. Can we see this from my physiology book? Yeah, here we are. So this is a virally infected cell here. And it's got viruses inside the cell. Because remember, viruses are obligate intracellular parasites. And then this cell is producing these triangles here, which are the interferon molecules. And these interferon molecules are diffusing to the cells round about. The cells round about have these specialised interferon receptors, which receive the interferon, and that affects these cells to reduce protein synthesis in these cells and to increase the production of the antiviral enzymes. So in these cells, these things happen. Inhibit protein synthesis, production of antiviral enzymes. And that's going to interfere with the production of new viral particles. So what essentially a virally infected cell is doing is it's forming a firewall around about itself to stop the spread of the virus. It's forming an antiviral wall around about itself by inhibiting protein synthesis in these cells so they can't make more viral particles. Won't do the cells any good, but once they've got rid of the virus, they can compensate for that usually, unless the virus kills the cells. And it will also produce the antiviral enzymes, and it will also stimulate immune cells, which are in the area, such as the B and T lymphocytes and other immune cells. So it all makes sense. If the interferon is down-regulated for genetic reasons, people are going to get sicker because the virus can run riot through the tissues. And that will mean that this phase of the illness is worse and there'll be more viral replication because the viruses won't be inhibited by the interferon. So it makes a lot of sense, actually. Now, some of you might think, well, what about the WHO Solidarity Trial? Check it out for yourself. We did cover this in quite a bit of detail at the time, that said interferon had little or no effect on overall mortality, initiation of ventilation, duration of hospital stay, and hospitalised patients. In other words, interferon was a waste of time as a therapeutic. But this was given to people that were already ill in hospital. Some might say that was a naive mistake. A study actually published yesterday that I haven't read thoroughly yet, but I'm going to go and it looks interesting. Nebulized interferon beta-1 alpha, that's the type of interferon that's produced early on in illness. For patients with COVID-19 on the 12th of November. That's there, and that shows that it does work. So the World Health Organization Solidarity Trial didn't work because the patients were already ill. You've got to give it earlier in the illness. And I really do find it strange that the designers of the trial didn't realise what I've just explained to you about this simple physiology of interferon, which seems to be the case. I mean, I'm sure you've got it just from that simple explanation and diagram. It's nothing too hard, but they didn't seem to account for that. That's strange. I can't explain that. Because the people designing these trials, I know silly people, that they are. This is what they do, and yet they seem to have made that mistake that some may consider naive. Anyway, getting back onto the current study about the genetics. So one is the lack of interferon, and the other is high expression of TYK2, which is another gene that upregulates inflammation. So this increases the amount of inflammatory cytokines. And again, this was found to be more common in people in intensive care. So it makes perfect sense. People that get sicker have a genetic predisposition to produce less interferon to protect them from the virus, but then they have a genetic predisposition to have a greater inflammatory effect. In other words, this bit here is greater. Now, it's not saying that is the only effect, it's saying it's one of the effects. We know there's other things that affect immunity and inflammation, such as vitamin D status. But there's no question that genetics is part of this, because all illnesses are a combination of genetic and environmental factors. Your genetics, of course, you're stuck with when you're born. So again, I used to tell my students, if you want to improve your genetic predisposition and your genetic health profile, then choose your parents really carefully. Some of them got it after a minute or two. Your genetics... It's wrong to say you're stuck with your genetics, because there's epigenetic factors, but most of those are set. Epigenetic factors is influencing the way that the genes that you are given, if you like, or the genes that you receive when you were first fertilised, when you were a zygote, 9 months before you were born. Those genes are what you're given, but what switches those genes on and off is determined from when you're conceived for about 1,000 days after that. So for the 9 months that you're a fetus, and then for the first few years of post-birth life, determines your epigenetic expression. For me, it's a little late, and if you understand what I've just said, for you it's a little late as well. Not too late for your children or your grandchildren though, so it's worth learning about. So one drug that might block this particular type of immune gene is this drug here that I'm not familiar with, but it targets this biological mechanism that upregulates it, and that has the potential to down-regulate that inflammatory mechanism. And it's a drug that's already used, so it would make sense that that could be used as an anti-inflammatory drug. Having said that, we've already got effective anti-inflammatory drugs, but this one could be more specific, so interesting. But of course, you'd need a clinical trial to work it out. Okay, now I'm going to just, I've got an email from Karen in London that's really quite revealing, really, about the ventilation. And I've been on and on about this, but it's still not being done. So I walked out of a hair salon today because of its poor ventilation. I arrived on time, so so she arrived on time, so she wasn't waiting near any other clients. I ensure they sit me down by the front door that's normally kept open, but the door was shut this time she went in. That all staffs wear a mask and not a visor. So the staff were wearing visors apparently and not masks, so she had to insist that the staff started wearing masks as well. So why they didn't know that, I've no idea. So despite arriving on time, I was told to wait near another client. The salon door was shut. It was hot and stuffy inside. The clients were packed in like sardines, less than a metre apart. The ventilation message is not getting through. I'm sure none of the people in the salon watch your YouTube channel. Otherwise they would be back safe at home like me, with unsatisfactory hair, but in good health now and for future weeks. Good point, Karen. I'm not surprised if London moves into Tier 3, the higher level, given what I've just witnessed. I also suggest the government gives better guidance to stores they're allowing to stay open during the winter. So lack of ventilation. Now, what Karen is describing there, again, it's virtually guaranteed transmission. So I think you did the right thing, Karen, and I'm sure your hair doesn't look too bad. Karen hasn't enclosed a photograph, but I'm sure she looks fine. But she did the right thing there by basically voting with her feet. So I think that's about us for today. Just show you a few pictures. Now, this picture series, what we've done is we're asking people to just send us in pictures using the Campbell teaching email. I'll put the link underneath. And it just a visual record of what the pandemic has been like for you. What images represent it for you. And this is from Danette in California. Now, what happens here is on his way into work, obviously a clinician of some sort, on his way into work, this machine, doodah here, takes your temperature. And then he goes to another desk and he gets a label for his work badge that says he hasn't got a temperature that day. I got the flu vac a few weeks ago, and I got a sticker saying I've been vaccinated against flu on my identification dangle thing. So that's a good idea. Temperature recognition. Of course, you could fiddle it, but you know we can rely on clinicians not to. I am sure. So that was quite an interesting one. This one is Ernst from Switzerland. And again, it's just what sums up the pandemic for Ernst. So hand sanitising, I think another clinical room, mask on the statue, all good. Oh, I like this one. This is from Kirsty in British Columbia. Practice safe social distance. 2 Great Danes or 7 Chihuahuas apart. I think that's brilliant. Face masks must be worn at all times. So there you go. Keep at least 2 Great Danes or 7 Chihuahuas apart. Ah, yeah. This is from Leslie. It's a Walmart picture. Other supermarkets are available, but I hope you can see this. So what you get is when you buy this garment, you get the matching mask. So I thought that was seriously cool that you get the matching mask, which of course is a really good idea. Okay, that's us for today. Thank you for watching as always, of course.